Welcome to MGov Management Training. This module covers integrating infrastructure and mobile technology. We'll begin with a discussion of scaling our servers and our services. Scalability means our ability to grow, our ability to take on more customers. So when do we need more servers? And how do we know when we need more servers? If we begin to see that our systems are slowing because of an overload of customers or traffic, this is an indication that we need to add more capability. So, how do we know when we need more servers? It depends on what sort of information our systems is carrying. For example, multimedia requires a lot of bandwidth. It is bandwidth intensive. We have a lot of data moving at the same time. For instance, if we're streaming videos from YouTube, this requires a lot of data across multiple channels at one time. On the other hand, we might have a registration site. We'll have less data moving perhaps at one time. However, there may be multiple sessions open at once. It's less intensive than multimedia, but you may have many users accessing your site just at one time. To prevent a crashing scenario, we need to understand thrashing is crashing. Thrashing occurs when your RAM is exceeded and the operating system must move data between the RAM and the page file. This results in an unstable system and you must reboot your systems. If there's thrashing, this is an indication you need more servers. As capabilities and capacity grow for mGov and SmartGov development, you should anticipate that your users are going to increase. Additionally, you need to increase the amount of data that you can handle at one time. So how do we add servers? We can add either physical servers or we can add virtual servers. To add a physical server requires a number of steps. We must purchase the new hardware and await delivery. We then confirm delivery and will inventory the hardware. We'll deploy it to the best available location in the data center. Then we cable the server to the nearest available switch, and so on and so forth. The last step in that plan is to ensure that we update our maintenance plan to account for the new server. As you'll see on your slides, this is a minimum of 7 steps to be able to add a physical server. To add a virtual server, we're just going to clone an existing server. It's extremely easy to implement. However, if you do not already have a virtual environment set up, the cost may be out of control for a smaller organization. You must weigh the pros and cons of either adding a physical server or a virtual server to support your increased users on your systems. Load balancing is a technique used to spread data across multiple servers, preventing servers from becoming overloaded. You can balance your network connections. You also balance for maintenance and for outages. For example, if I have servers A, B, and C, and server C needs to be taken offline for maintenance, I can balance the load only between A and B in order to perform the maintenance on server C. Once the maintenance on server C is complete, then I can again run traffic through that server. I've spread all of my data across those 3 servers. Additionally, high availability is a technique also used to help balance the load of our information. However, high availability is more like redundancy. We create a failover spare in case of any issues. Servers can be paired, and a standby server may detect when the active server goes down. The standby server will then pick up the traffic. Therefore, users should see no downtime in their services. How we balance loads and create high availability has a lot to do with system criticality. Additionally, we want to ensure that those systems that are the most critical have the most support around them. We never want to see those systems slowed due to an overload of users. You may identify your critical systems so that you can plan and prioritize accordingly. The United States Department of Defense defines 3 mission assurance categories, which you will see listed on your slide. The most important issue to cover here is Mission Assurance Category 1. These are the most critical systems. The loss of these systems would be devastating to operations. Most importantly, if these systems were affected, there is the potential for the loss of life. Lives could be lost. Organizations would be immediately incapable of operating, and these systems support continuation of life in some manner. For instance, the systems in a hospital, if they were to fail, this could cause the loss of life. Additionally, services like the police or civil defense are also categorized in Category 1. Mission Assurance Category 2 are also important, but they're not critical to operations. And likewise, Mission Assurance Category 3 includes non-essential systems. Systems in this category include things like email. They're non-essential because I know I can still complete transactions and do work for my organization through other means, such as the telephone. Continuing from our previous discussion, also important to the issue of scalability is how you will support your infrastructure. The back end of your operation is critical to your overall success, as we previously discussed. Your ability to grow and handle increased number of users is essential to users having no downtime. Hosting your services is at the heart of your operations. If you do not have the proper amount of servers and the power supporting your applications and your data, you'll be faced with issues such as application latency. Problems with your application will lead to user frustration. User frustration will result in losing customers. The first way to host your back-end services is internal or on-site. This is my building, my equipment, and my data. This is a very secure operation because we have direct control of the building and all of the access policies. We can say who can access and when they can access our site. However, it's also very expensive. We have all of the expenses of our equipment, but we also have the expenses of the facility, including electricity, air conditioning, water, fuel, etc. We have the responsibility for all on-site staff, including security. We also have the responsibility for training and educating staff on new technologies that are incorporated into the data center. The next type of hosting is called co-located. This is your building, but my equipment and my data. This is essentially renting a space in a pre-existing data center to hold my equipment and run my operations. This is a moderately secure setup, but we may not control access at all levels. Network access controls will exist, but only to a certain degree. Access policies are actually written by the building management. We'll have no say in who accesses the building and when. This also makes it only moderately expensive for us. The leased space reduces our cost. We have no cost for the facilities, such as electricity. These are all the responsibility of building management. The third possible way for hosting is in the cloud, or also known as IaaS, infrastructure as a service. This is your building and your equipment, but my data. It's very difficult to ensure security in this scenario. There's no physical access control whatsoever. No control of also the equipment that runs my applications. We have no input into maintenance windows, decommissioning or the refresh of equipment, or the security of storage devices. This all becomes the decision and policy making of the vendor who's offering this infrastructure as a service. It's also the least expensive way to host your data because it's the least space and least equipment, and we have no staff responsibility. All of those costs and responsibilities are with the data center vendor. This reduced cost also means a reduced oversight of our data. We have no way to control physical access to the equipment, maintenance windows for our equipment, or the staff that can access the building and the equipment itself. This ends the module on infrastructure.